It is no question that the future will be automated and autonomous. The only question is when and how. But what is for sure, it will definitely transform our everyday life. However, today we are here to discuss a more specific consequence of this autonomous world, namely its potential impacts on telematics. Personally, I've been working with autonomous vehicles and telematics for more than 20 years, also representing Hungary as a member state in several European Union initiatives for connected and automated vehicle technology deployment. And I'm luckily in the position that I can efficiently combine scientific knowledge and practical experience in my everyday life. The sponsor of today's webinar is Inventure Automotive, that I represent as founder and owner today. I will cover my two other roles later. According to the definition, Inventure Automotive is an in-car technology enabler company on the telematics aftermarket. Our core competence is to extract tons of information from the vehicles. Practically, it means getting out of all kinds of electrical signals from all types of vehicles, regardless of being agriculture machinery, construction machinery, lorries, special utility vehicles, heavy-duty commercial vehicles, buses, passenger cars, or even boats. And I would also like to mention that it is also regardless of the drivetrain, whether it is an internal combustion engine or an electric drive. Currently, Inventure supports off-the-shelf more than 1,200 different vehicle models now. Since different vehicle models speak different CAN languages, Inventure not only collects, but also interprets, translates, and standardizes the data that we are collecting from the vehicles. Our main market is the telematics market, but we clearly see that our market is shifting towards the data-driven companies like ICT companies and mobile operators. Today, I would like to invite you to a journey from the autonomous mobility challenges to arrive at the future perspectives of telematics. My presentation is divided into 4 parts. At the very beginning, I will introduce you to the current challenges of autonomous vehicles. In the second part, I will introduce you some of the research fields that is ongoing on this field. On the third part, we will arrive how much and how massive data these future is generate. And last but not least, at the end of my presentation, we will arrive on the impacts on telematics. So let's start with the basics. Safe autonomous mobility needs thorough prior testing. And this is why the Hungarian government decided to invest into this Zala zone infrastructure, which you can see on the right side of the picture. I'm really proud that I took personally part from the very beginning, from the design and during the construction within this proving ground. What you can see is here, it is a 2 kilometer times 2 kilometer area, 265 acres. And this covers all these facilities that can incorporate so-called conventional or standard vehicle testing. But the unique thing in this proving ground is that this was initially designed for the connected and automated vehicle testing requirements. So we identified 8+1 unique testing propositions within it. Let me go through some of these facilities. This circle here, which you see in the middle, is a 300-meter diameter, ultra-flat asphalt surface. It is called the dynamic plate. And on this dynamic plate, you can do whatever maneuver safely. You can also find here a braking platform with 8 different frictional coefficient surfaces for braking tests and for ABS tests. On the further side here, you can see a dedicated platform which is under construction for advanced driver assistance tests. So ADAS testing, and you probably heard about like Euro NCAP tests. Here on the further part, it is called a high-speed handling course. It is a 2-kilometer long, mostly like a racing track. You can drive on it with an average of 120 kilometers per hour, and its purpose is to test the suspension system, the steering system, and overall the vehicle dynamics of the vehicle. Within that, you can find the construction of the low-speed handling course. What is very unique, for example, this 1.5 kilometer long motorway section. This is a standard 2-directional motorway section with 2 lanes plus an emergency lane on one side, also with a straight curve and also with a curvature. And this is unique because a motorway section cannot be found on any proving grounds on a global scale. Why we felt it is important to build a motorway section? Because we feel that with automation, the first potential level 4 automation will arrive on a motorway when you can give the control over the vehicle, and the vehicle will be able to drive safely during a motorway running. So for this reason, we built a motorway section within the proving ground. And in the middle of the picture, you can see a smart city zone, which is a 20-acre artificial urban area. You can see the skeleton. So all the roads are available there. You can see, for example, a high-speed multi-lane area. This is 700 meters long, 2 times 4 lanes. But we also have a logistics yard for automated yard maneuvering testing. We have all the parking lots, a parking garage here. Here we will have an in-city area, a downtown area with higher building facades, which will be available around the end of this year. We will have also buildings on the suburban area made from brick and wood. And all these building facades will be built from real construction materials so that they have realistic reflections, not only for the cameras, but also for the radars and additional sensors in the vehicles like LiDAR and ultrasonics. So this is basically the proving ground that we believe will play an important role in the testing of the vehicles before they can go on public road. Why it is important to test those vehicles? You might also have observed that within automation and within this autonomous mobility, there are companies coming from 2 directions. One is, of course, the automotive companies, which has learned during the 112 past years, is that safety first, safety second, and safety third. So they put everything all above safety. And there are also companies coming from the software section, IT companies, which might take it usual that a beta version of a system can be also delivered to the customer for the final stage of testing, which is really not usual in the automotive sector. And due to this very big market competition, we have to be careful what kind of vehicles are appearing on the market, because potential accidents could set back the public acceptance of this technology for decades. So this is the reason why we feel it is really important to do the tests before they can go on public road. And this is the reason why I feel Zalazon provides the perfect environment before going on public roads. There are ongoing research all over the world trying to find solutions. So as our automated drive laboratory at the Budapest University of Technology, where we formulated our approach towards this research area into a pyramid. This pyramid is called the Autonomous Vehicle Testing and Validation Pyramid, and it starts from virtuality and it is going up to absolute reality in 5 different layers. Let me start with simulation. Simulation means that we are within the computer world, we can also reproduce reality. And within this simulation, we can gain really valuable results. And these simulation results will also take part in the type approval process. So for example, within this simulation, we are using state-of-the-art simulation tools, and we already implemented Zalazone with centimeter precision within this simulated world. On the left side of the picture, you can see a screen showing the digital twin of Zalazone, meaning that we replicated the real Zalazone where this test vehicle is running into the digital world. This real vehicle is represented here, and it is displayed at the same time through 5G communication in virtuality. So what we created with mixed reality testing is that simulation and the real testing can go parallel. And also you can see in this picture that nobody is driving this vehicle, so it is fully autonomous. And also you can see in the video that there is no real vehicle in front of us, but there is only a virtual vehicle in front of us. And this virtual vehicle acts like as it was a real vehicle in front of us. So the real vehicle could run and perform, in this case, ACC test, so cruise control, adaptive cruise control tests. So this is simulation. One layer above, there are laboratory tests. So we have certain types of laboratories at Zalazone, and layer number 3 is the proving ground itself, which provides a safe environment for testing. But once a vehicle was proven to be safe within the proving ground premises, they can go out to public roads. First to the city of Zalaegerszeg, and later to any public roads in Hungary. I do not know whether you are aware of that, but Hungary made a decision in 2017 April. So the government modified the Hungarian legislation, and since 2017 April, it is legal to test automated vehicle functions on public roads in Hungary without territorial limitation and without timing limitation. So once you get the license, you are allowed to test your vehicle on all public roads without any timing limitation. Let me show you a video which summarizes the challenges of these researches. You can see the vehicle is absolutely autonomously driven. And you can also observe that this pedestrian is resulting on the same effect on the vehicle when we push a virtual pedestrian in front of it due to this mixed reality testing that I was mentioning you before. During this scenario in the loop concept, the simulation and reality runs parallel. You can see that it is happening in real time due to the ultra low latency of the 5G communication. And the front vehicle was generated in the virtual environment. And we were also able to demonstrate automated vehicle control over 5G in an automated overtaking maneuver as well. We carried out a joint research with the European Commission's private laboratory, the JRC, where we carried out a market survey using state-of-the-art brand new vehicles and compared the performance of their ACC functions. And also we are dealing with automated vehicle control on dynamic limits. Which shortly means autonomous drifting. So I really hope that this video highlighted the uncountable challenges of automated driving. In the next section, I picked out 3 relevant examples which could influence the future of telematics. And let me start with the digitalized HD map. HD stands for high definition map. Probably you are or all of you familiar with the navigation devices within the vehicles that are capable of directing the driver into certain directions, and they have a network of the road sections behind. But when we are talking about high definition map, it means a centimeter precise representation of the real world into the digital world. And it is created in a way that there is a laser scanner. The laser scanner scans the real environment, and the laser scanner creates a point cloud, a laser point cloud. And from that laser point cloud, either we can create digital maps, or either we can create humanly visible digital representation of the surrounding, so as called digital twins. These HD maps can also be fed into the vehicles so that the vehicles can navigate, and they know exactly not only the road geometry, but also the position of the lane markings, also the road furniture, also the traffic lights control, and so on. So this is what we call an HD map. And I would also encourage you to download and test the Zolazone HD map, which are available freely on the Automated Drive web page. So you can also download the HD map. You can also download the Zolazone simulation models in more than 8 formats for simulation tools, and you can perform a virtual test drive at Zolazone. In the next picture, I would like to introduce you a little bit to this future autonomous transport. Within this future autonomous transport, not only the vehicles will be intelligent, but also the infrastructure will be intelligent, and they will share information with each other, and thus they will create a more safe and more efficient transport. Let me go through this. On the top side, you can see the 3-dimensional point cloud that was laser scanned. And as I told you before, it can be filled up with rendered picture of the university premises, because this is our university at Budapest, creating the digital twin of the static environment. On the bottom, you can see that we already implemented and mounted infrastructure sensors within this environment, optical cameras and LiDARs. We also have a vehicle equipped with LiDARs, cameras and radars. And what we did is that based on an artificial intelligence-based algorithm, we can combine or fuse the sensor signals. And what is really unique, that our algorithm can real-time make this fusion, and they can real-time represent in the digital twin environment, for example, pedestrians that are running around the vehicles and the infrastructure, and they do not have any special sensors, but they are sensed by the infrastructure sensors and the vehicle sensors, and through this AI-based fusion, we can place them real-time in the digital twin. Should you be interested in more in this concept, you can see a video on the link below. The third thing that will also have a strong impact on telematics is communication. You can see now a section of a road where there are intelligent vehicles are running, and also this infrastructure is equipped with different sensors, as I explained you to before. To be able to exchange the information and provide enough valuable data for this AI-based sensor fusion that I mentioned, we definitely need very low latency communication. This is called URLC communication, ultra low latency reliable communication. And this can be provided also 5G communication, for example, or DSRC communication, or in Europe, ITS G5 based communication. So we believe that the future transport is directed towards this direction. We are not just scientifically talking about this future. So for this reason, together with our road operator partner in Hungary, Hungarian road operator, Magyar Közút, we closed a 3.5 kilometer section of a motorway in Hungary for 3 days for testing. We incorporated 13 test vehicles that were equipped with such sensors. So all the 13 test vehicles were capable of driving in an autonomous mode. But the most important thing was that they were equipped with centimeter precision GNSS localization and positioning system. So before we created these tests, we also surveyed with laser scanners the whole area. So we created the digital twin of this 3.5 kilometer area. We equipped the area with infrastructure sensors, and we collected these 30 test vehicles. We identified 52 test scenarios that we put together, and since one test scenario in average were run 2 or 3 times, altogether we had almost 160 test runs during this 3 days measurement campaign, where we also carried out not only daytime measurement but also nighttime measurement. And just to have a quantitative understanding about how much data was generated, we collected and measured more than 1 terabyte data. Approximately half of them were coming from the vehicles and the vehicle sensors, and half of them from the infrastructure sensors. On the bottom link, you can see and you can access a scientific publication describing this measurement campaign in very details. When we talk about the data amount generated during autonomous driving, we have a benchmark comparison to the human brain, and what we can also take a look at the forecasts. McKinsey says that in a connected vehicle, 25 gigabytes per hour data will be generated, which I believe quite well corresponds to our measurement campaigns experience, where we created 1 terabyte plus data during this autonomous test. And there are also researches telling that with the autonomous vehicles containing many video cameras, also internal computers, localization systems, and inertial measuring systems, they can also go up to 5 terabyte per hour data generated. Meaning that there will be a massive volume increase in the data amount due to this autonomous transport, meaning that we are arriving at a big data problem. So if we look at this step back 2 steps, we can see that this is a generic big data problem because we face an extreme amount of data. The second thing is that we have various data sources. Today's telematics are only focusing on a couple of data, and with not that much of repetition time. But in the future, they can access data from more than 100 sensors within the vehicles, and also from the communication devices. And not mentioning that we can also incorporate the information coming from the infrastructure sensors. So the data sources will be widened dramatically. And the third very special characteristic is the temporal characteristics of this data. So not only static data, but also dynamic data will be available. What are we talking about when we talk about static data and dynamic data? Let me provide you some examples. When we talk about static data, you have to think about the road geometry, the road section or the road furniture, which is built and it is staying in that manner for years ahead. So this is static data. When we talk about semi-static data, you can think of a road construction. A road construction means that a certain area of the road is closed temporarily for a couple of weeks. So this road section cannot be used by the traffic. And this can be a useful information when we organizing the traffic flow. We can step one further for semi-dynamic data, when we can also say that, for example, a a tree is falling on the road section, and this tree is preventing the traffic ongoing, or an accident happens. When an accident happens, it might close both directions of the vehicle for a couple of hours. This is called semi-dynamic data, which could be really valuable if by that information you can avoid the traffic jam and you can continue your route on a detoured way. And when we arrive to dynamic data, where, for example, a pedestrian crosses a zebra crossing, can last only 10 to 15 seconds. And this information is, of course, not relevant to those who are traveling 100 kilometers away from this location. But this information can be really life-threatening or life-saving when your vehicle is running just nearly this zebra crossing and you are warned that a pedestrian is currently crossing this data. So we proved that this is a big data problem, and we would like to understand how does it affect telematics. But before we go there, let me explain you the levels of automated driving. The levels of automated driving were defined by the SAE, the Society of Automotive Engineers, into 5 levels, from level 1 to level 5. So from this point of view, level 0 means driver only, which we used to drive in the past. So the driver is carrying out all the tasks. In level 1 automation, which we call assisted driving, the vehicle is responsible for either steering or for either accelerating or braking the vehicle. In the market, one can buy such vehicles with a lane keeping assistance system or an adaptive cruise control system. They are level 1 automation systems. When we go to level 2, it means that the vehicle is taking control of both the longitudinal and both the lateral control together. But it is really important that still the driver is responsible for the safe operation of the vehicle, and the driver has to take care that the system is capable of performing the automated vehicle control in all the circumstances. And the driver is responsible to take over whenever a dangerous situation occurs. In level 3 driving automation, which is called conditional automation, both the longitudinal and the lateral control is handled by the vehicle, but there is one very big step forward by means that the responsibility is now by the system, by the vehicle, or by the vehicle manufacturer. So in level 3 automation, it is the system that has to take care whether the vehicle can control or can drive the vehicle safely in a certain environment. And when the system identifies that is beyond the vehicle's capabilities, it must warn the driver to take control back. So the driver's responsibility is only being available and taking back control in case the vehicle wants to give it back. Level 4 automation is called high automation, and it means that the vehicle can take care of all the driving tasks, but in specific driving situations. For example, in a parking lot, or for example, what I mentioned, in a highway. So in a highway, we enter the highway, give the control to the vehicle, and we can have a rest, and the vehicle takes care of the longitudinal control. It accelerates, brakes, changing lanes, and we are getting back the control after 200 or 300 kilometers when we are leaving the highway. So this is level 4 automation. And level 5 automation, which is a little far future, because it means level 4 automation in all driving situations. So level 5 means that there is no need for the driver in any of the situations. But what does this mean from the telematics perspective? It definitely means that as we go up with the level of automation, the control of the OEMs are increasing, and vice versa. the potential for accessing the data and new data for the aftermarket solutions and for the telematics is potentially decreasing. And this causes a definite risk for the telematic companies, because OEMs are understanding now more and more the value of data, and they would like to keep the control over the data, exclusive control. And as much as possible, they would like to eliminate competition. Of course, there is European Union who will mandate to give access to those data, but when they will provide access, definitely they will be potentially on higher prices, and that would reduce the customer options and the choice. So what are the options for the telematic companies? Of course, there's a chance to become an OEM, telematics service provider, which could be a really good future vision. But of course, this is not available for all telematics service providers. What they can do? They can strengthen their OEM independency by providing multi-brand solutions, because most of the fleets are not focusing on one brand or two brands. They are mostly composed of several vehicle models and several brands. And also by increasing the data volume and the dynamic manner of the data by means of having higher update rates, and also expanding the access to additional data and building up new use cases to this data, they can provide tailor-made solutions, tailor-made analytics to the customers. And also using these data that they can access, this higher volume data, they can also create data-driven personalized analytics and more customized use cases. Check out our favorite example, how we can prove that Inventure is already ready to provide reliable access to various vehicle data. To be able to control a vehicle on the dynamic limits autonomously, the control algorithm requires special data and on a very high update rate, so 10 milliseconds, meaning 100 times a second, high resolution vehicle speed for every wheel, steering angle, engine torque, gear, and so on. And we are really proud that Inventure could provide a solution for the researchers to build this information into the control, and by using that information, they were capable of controlling the vehicle on the dynamic limit, which is only a few researchers and few universities on a global scale can do that. Today, everybody focuses on a small amount of data, and especially on fuel consumption. But if telematic companies build use cases for other parameters too, this can be a definite competitive advantage. If you haven't tried the Inventure technology that can provide all these data, I would encourage you to test it by our starter kit, which starter kit composes of our CAN sensor, our FMS gateway, and also the cable sets that provides an instant opportunity for the testing. The starter kit FMS gateway is initially programmed with a simulation firmware, so that for the very first tests, you don't need any vehicle at all. You can start the simulation firmware within the gateway on your desk, connected with your telematic appliance, and test how these data can fit into your system. And after that, you can reprogram the firmware in the gateway. You also provided installation manual, and you can go out and perform the vehicle tests with the special firmware. Today, we invited a special guest also to enlighten the same topic from another perspective, and also to validate or to argue with our views that I presented to you. So let me warmly welcome and introduce you Dariusz Terlecki from Webfleet Solutions. Servus, Dariusz.
Hello, servus, yeah. Good morning, Zsolt. Good morning, Alenka, and everyone.
Thank you very much for accepting our invitation, being a special guest for today. And the floor is yours, Dariusz, please.
Thank you. Many thanks. Many thanks, Zsolt, for introducing me. And first of all, thank you for opportunity to participating in this great webinar in front of so professional, valuable audience. I'm happy especially because as Webfleet, we have cooperated with Inventure for years, among others, in terms of CAN data providing, exchanging. And I believe that after launching Webfleet onto new markets in Europe and not only, amongst other Hungary market, what was happened last weeks, we even make deeper our partnership, being able to provide altogether more value for mobility, for whole telematics environment in Hungary, in Central Eastern countries, and without any limitation all over the world.
Thank you very much.
Moving to our presentation. Yeah, thank you for clicking. Moving to our presentation on the merit. Whilst connected, electric, and shared. Please move back one slide. Yeah. When connected electric, shared mobility is the future, the autonomous fleets is not here yet, but it's coming soon, very fast, and we would rather be prepared for it. According to McKinsey and Company, in 2040, it means in 19 years, autonomous vehicles will make up to just over 40% of new vehicle sales and around 12% of the vehicles installed base. Please click. So, yeah, thanks. For sure, autonomous commercial mobility promise to give way to a range of opportunities. Amongst their many benefits, optimization of fleet efficiency is the most obvious. Vehicles utilization. Let's not forget that by effectively eliminating off hours of drivers' breaks, meal times, night stops, etc., AV, autonomous vehicles, could theoretically operate 24 hours per day. What's even more, autonomous vehicles would help fleet managers to optimize fuel consumption, but operating at consistent mileage rate and platooning. Just like a cyclist in the Tour de France or Vuelta a España or Giro d'Italia, for example, trucks following another trucks, faceless drag and save fuel. AV could reduce also the industry's impact on the environment. Furthermore, contrary to some people's beliefs, autonomous vehicles can improve road safety, especially taking into consideration that human error is responsible for 95% of accidents on the roads. Finally, AV, autonomous vehicles, offer a solution to the driver shortage that's affecting many countries across the world. For example, in USA, there is a 60,000 shortfall of drivers, which is only set to worst as more of truckers retire or the job appears increasingly less appealing. Zsolt, please click. But however, this coin has also second side. There still remain many challenges that came with autonomy. Dr. Zsolt Szalay has already told us about massive volumes of data that must be managed. We should take into consideration it. Security risk, concerns to privacy, open to the new vectors of attack. In a recent survey by Deloitte and Touch, 48% of Americans surveyed agreed that autonomous vehicles, they feel like not safety. Along with safety concerns came liability concern. In the case of accident, who will be held responsible for it? This is the open question. In many cases, our roads are simply not ready now for the takeover of AV, autonomous vehicles. We must think about car parking, last mile solutions, as well as digital infrastructure like sensors, smart traffic lights, digital mappings, if we want to see AV, autonomous vehicles, as a reality on our roads. This comes to a cost and investment which countries must put on the table when they think about autonomous in very early stage of development of AV. Please click. Telematics will continue to be the eyes and ears and the hands of tomorrow fleet managers, definitely, even in the era of autonomous fleets. Telematics will need in the future, however, will have to expand today's capabilities to harness on ever more complex mobility. Power for analytics and reporting. Being able to use the data to take proper decision will be key now and in the future, of course. Smart cities. Managers will have access to the data from roads, traffic signs, charging station line markings, road signs, and the traffic lights can wirelessly provide information to the vehicles and vice versa. Data from connected vehicles and road users may provide valuable insight, of course. Few examples only. Electronic brake lights, which allows a driver even though they might be obscured by other vehicles, for example. Or platonic, which allows vehicles to closely, down to a few inches only, follow the leading vehicles like electronically coupled road trains. Please click. Then complete data and vehicles to everything communication. Just like Dr. Sorry, Zsolt, if you could move back one slide. Yeah, like Zsolt said in the past, yeah, thanks. Telematics platforms will have to interact with different data standards and with new data formats also. This will require reliable vehicles to device and vehicles to network communications. We can call it vehicles to everything even. And the last but not least, artificial intelligence. Having vehicles capable of operating around the clock. Who will be there to make decision when the fleet manager takes a break, for example? Artificial intelligence could use of preset algorithms to temporarily take responsibility. And telematics must be ready for it and think about it even just now. Now, please click. Yeah. Data insight will continue to be essential for the autonomous fleets now and in the future, absolutely too. Nowadays, our technology does a lot more than track and tracing, telematics technology. Even now, our solution helps fleet managers cutting fleet costs, increase efficiency, assuring safety, and enabling environmentally way of working. The same will be true in age of unmanned commercial mobility. Now, going forward in my presentation today, I want to concentrate on autonomous fleet solution, of course. You can hear how web fleet solution is fully integrated with Bridgestone and how we are leveraging case synergies to add value for our customers and contribute to society. Web fleet solution, I would underline, is currently even now a leading developer of digital mobility technologies and #1 telematics service provider in Europe. And based on that, this picture, I would say that this picture you can see here is not a map. It shows the footprint of our connected vehicles. These are vehicles that are sending detailed data every minute from their movement, from their ongoing operation. Then we process over 70 billion data props per quarter. And we translate this data into actionable insight for our customers and partners. Then you can see here our market heritage is rather mainly European. So seeing below what is essential in web fleet services provided in the frame of telematics to fleet management and telematics companies. Yes, please click. Yeah, we can, okay, thanks. Summarizing, I would like to say that autonomy could create a lot of opportunities, of course, like growth of efficiency, of safety, but parallelly challenges, like manage massive data or mitigate security risk. But still, generated a valuable insight would be essential to making better decisions just now and in the future, definitely. And I deeply believe that Webfleet as a telematics operator, together with Inventure, of course, will be able to offer very complete and valuable solution portfolio in current and future mobility world. Then, thank you for your attention, ladies and gentlemen, and I moving back the voice to you, Zsolt. Thank you again.
Thank you very much. Thank you very much, Dariusz.